Hey everyone, I'm Tony Lyons, and welcome back to another CG Compositing series video. Today we're going to be talking about light groups. Now, if you remember back to one of our first videos, we were breaking all of the CG renders passes down into kind of four categories, and we split that down the middle between beauty rebuild passes and data passes. And we're going to be focusing on the light group section. So we have finished our Material AOVs section, and now we're going to be talking about light groups. And the kind of main thing to mention here is that when we rendered all of our Material AOV passes, they all added up to rebuild the original beauty render. And the same is going to be with the light groups. So all of the light groups will also add up to be the beauty render. And they won't add along with the materials. So it's like a separate rebuild, if you will. But just know that if you add all the Material AOVs together, it should rebuild the beauty render. And also if you add all the light groups together, it also should rebuild the beauty render. Light groups, in a nutshell, are when you take all the lights in the scene and you split them up into either individual or groups of lights, and you render them into separate layers so that you can control them after. In the fruit ball render, we have some various lights with angles and colors, along with the emission material. So depending on your scene, you might have a lot of these or a few of these. Just depends on how complex or how split up the lights in your scene you would like to have control over. So jumping into Nuke and revisiting our AOV rebuild, where we had all the sections like diffuse and spec and emission, the light groups rebuild is going to be quite a bit smaller and probably much easier to understand. We just shuffle out all the light groups in whatever order that we want. I named them numerically, but they might be different names like fill light or key light or something. And you shuffle them all out. You plus them all together. There is no multiply, divide, or anything like that. So you just add all the light groups together. And where we started with our beauty, we can see the scene kind of slowly build up until it reaches the beauty. And here was the beauty render, and here is the final. So yeah, just shuffle them all out and add them all up. If you're missing any or you see any leftovers, you can always add up everything you have and subtract it from the original, and then you have kind of the leftovers in case you need to plus that on. But yeah, quite a bit easier to understand compared to all the explanation that we went through with the Material AOVs. The fruit ball might not be the best way to illustrate the light group, so I have a Blender render here. And luckily, a couple of years ago, they added the feature to actually export the light groups in Blender. And so here I just have the different lights that are in the scene. It's like the more prominent lights in the scene, including the emission objects. And here, actually, we group them into like key light, environment light, rim light. So things that are essential for maybe the story of what's happening. And as you can see here, it might be more illustrative that the scene is building up and the lights are building up one at a time until they finally reach the beauty render here. And so that is the goal of the light groups. They should add back up. You can now creatively adjust the different lights in your scene to come up with an entirely new scene. Maybe you want crazy room light, and I don't know. It's you can get some different types of images. That about wraps it up for the light groups video. It's very easy to explain. And I guess that's the end of the video. Thanks for watching. No, I'm just kidding. This wouldn't be a compositing mentor video if I didn't go into absolutely unnecessary detail into this subject. So that is what I'm going to do. So for anybody who wanted a quick overview, there it was. And for all the diehards out there that want to learn some cool stuff, stick around. I'm going to dive into what they are, why we use them, how you can use them appropriately to be a better CG compositor. Let's dive right into this. So, what is a light group? A light group is a render pass of a light or set of lights in the scene that is rendered in isolation from the rest of the scene's lights. All of the other lights are off and only the light group's light is on and affecting the scene. All of the light group passes should add together to produce the full lighting in the scene, so they all plus together and build back the beauty render. What is the importance of light groups? We already have all those Material AOVs. Why do we need to render more crap in our scene in the form of light groups? So creating good looking CG is not just about the materials of the objects, but it's also about the lights in the scene that interact with those materials and tell a story. Different light types can drive the aesthetic, style, realism, or story of your CG render. Understanding lighting basics is important for being an effective CG compositor. Some of the more common light types that you might see are listed here, and I'll go through them one by one, but if you've ever taken a lighting class or photography class or whatever, you'll be very familiar with these, but let's just go one at a time. So key light, which is kind of the primary light source. So think of the sun, or if it's a night scene, a moonlight, a window that's shining into an architectural rendering, or a spotlight on a stage, something that is the main source of light. Fill light is something that lifts and softens the shadow. So if we just had a key light, it would be very harsh, right? Like a spotlight on a dark stage. So we add some bounce light to fill in the dark parts and make it a little bit more even. That might be stuff like a sky dome. So if the sun was the key light, then the sky of blue would be the sky dome, which would fill up the scene. Or any type of bounce lights that are bouncing off the ground, or bouncing off a white card or something. That would be fill light to help boost those shadows. So rim light is specifically designed to enhance silhouettes. So if you're filming a dark thing against a dark background, you might not see where the edge of that thing is. And the rim light is used to kind of catch highlights on the back of an object and kind of make it a silhouette there. So any type of backlighting or hair light, so light that's specifically designed to light up those edges and separate the foreground and background, that would be an example of a rim light. Here you can see a quick example of three-point lighting, the notorious three-point lighting that we all learn about. So this is the classic key light, fill light, and rim light to enhance the silhouette. So yeah, here you can see the actress broken down in the key light. That's the main light. The fill light, that is supposed to add some bounce into the shadow, so her face is not so harsh in these areas. And then the rim light, that's bringing out the hair and giving it a bit of boost from the background there. So that this is all of them combined: key, fill, rim. I'm definitely not going to teach you how to light in this video, but yeah, these are kind of like fundamentals that you learn if you're taking a photography class or just a basic lighting course. I know that's sort of fallen out of fashion with us taking like HDRI images and recreating like all the lights in the set and however they're positioning, but if we're recreating lights that are on a film set, they might be doing some three-point lighting there, so good to know about. So practical lights or practical lighting is something you might find in photography where the light sources that are in the scene are emitting light into the scene. So it's sort of removing the artificial lighting that instead of having a giant light on the set, you might be using things like screens or street lamps or accent lights or candles or something just in the background, kind of as the source of light in the scene, lighting it up. Here's some images to describe the practical lighting. On the right side, you can see the scene that is just mostly lit by these practical set lamps. So you can imagine they don't have any other main lights or set lights in the scene, and they're just using these practical lamps to light the scene. And we have a CG render here, but you can see the kind of same principle. Yes, you have kind of this moonlit sky, but we're using these little lights here and then some little lamps to kind of light up the scene in a little bit natural way. The name practical lighting, I suppose, comes from the fact that the lights serve a purpose other than making a rim light on the character so she looks cool, So they have a purpose in the scene, but they're also, lighting the scene in a nice way. So interactive lighting, these are dynamic lights that are changing over time. So we have to have a lot of control maybe to flicker them or turn them on and off. We have an example of like police lights that are moving back and forth and, so that they're strobing a bit. A fire, which is a randomly flickering light source. Lightning, which is, as the lightning hits the characters, they are being illuminated by that lightning. So that's a form of light that we need to take into consideration. And then we, of course, have our magic effects that are emitting light. And we have the great Harry Potter film as a reference there, that the whole scene is being basically lit by the magic wand power. It is, of course, probably the one that the compositor needs to do the most to, because anything could be affecting the scene, and it could be a timing of an effect, or it might need to turn on at an exact moment or something. So yeah, good to have that as a separate light source so the compositor has full control over those. So now we know how a lighter might split up these lights in the scene into different light groups, but what about what is important about light groups for compositors? Compositor is usually focused on two main aspects of lights using the light groups. The first is exposure, or how bright the lights are. And the second is temperature, or what color or hue the lights are. Both exposure and temperature are really the main things that we want to be adjusting in our lights. And one of the reasons is that this is how lighters adjust the lights in their 3D scenes. So besides like moving the lights closer or farther apart, they're adjusting exposure and temperature in the 3D application. So we can kind of mimic that in case we need to round trip some of the changes that we did in comp back to lighting. It's definitely not the only things that you can do with light groups. You can do other types of color corrections or masking and such, but if you want to kind of keep it in a world where you can keep it in the world of lighting and go round tripping back to 3D, you want to adjust exposure and temperature first, see how far you get with those settings, and then you can start going into a little bit more detailed color corrections. So let's do a deep dive into exposure and temperature separately, and we'll see like what we mean by them, where they're coming from, some terminology, and how we as compositors can adjust them intelligently in our comps. Exposure. What is exposure? Exposure is the brightness or the intensity of a light, and exposure is usually measured in stops of light. You might have heard a photographer or a VFX supervisor say, make that one stop brighter or two stops darker. So what do they mean by stops? What does it mean for us in how we adjust our lights to reflect what they're asking for? So stops are relative. That means that they're based on what you are currently looking at. So wherever your image is right now, it is where the 0 point is. That's like where we're starting from, right? So if somebody says they want something one stop brighter, that just means that they want it twice as bright, right? So double the intensity. So multiply 2. And if they want it one stop lower, that's just half as bright or halved. So half as intense as the current image that you're looking at. This is exponential, right? So 2 stops is not twice as bright as the current image. It's twice as bright and then twice as bright as that. So it's 4 times as bright and then it's 8 times as bright. So you get double, 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 or half, half, half. And here's an example in photography where if this was our starting image, we would go 2 stops up, and that would be double the first one and then double the second one. So the plus 2 stops is actually 4 times brighter than the original, and then plus 3 is 8 times brighter. And the same applies when we lower the stops, but it's going kind of towards a fraction. So it's 1/2, and then it's 1/4, and then it's 1/8. So in other words, it is exponential. Exposure is also a key principle in photography with something known as the exposure triangle, and that is the relationship between shutter speed, aperture, and ISO when you're taking photos. The rule of this triangle in a nutshell is if I take any one of these 3 sides here, let's say aperture, and I raise it 1 stop, then I need to pick one of the other 2 sides to lower by 1 stop, let's say ISO. So I need to lower either ISO or shutter speed by 1 stop in order for the image to remain the same brightness. So in other words, if I double one of these, then I need to half one of the other ones. If this is an entirely new concept for you, then I'll just really briefly go over what these are doing. Aperture is how big the opening of the lens is. The larger the lens opening, the more light gets through and the brighter the image. Also, the bigger opening results in a shallower depth of field or a smaller zone of focus, and this results in larger bokeh shapes and further separation of foreground and background. So you see here of f2, where it's quite open, it's a large aperture, and there's a very shallow depth of field. In other words, the focal point is very small, and more of the image is out of focus. And if you close up that lens hole, then you get a small aperture and a deep depth of field, which just means that more of the image is in focus. Shutter speed is how much time the opening of the lens remains open for, measured in fractions of a second. Leaving a lens open for longer lets in more light and brightens up the image. Longer exposure time, so open for more time, will result in more motion blur depending on the shutter speed and the speed of the object that's being shot. Here you can see a woman skipping with different shutter speeds, and the faster that the lens closes, the more sharp the image is going to be, and if it's left open for a longer amount of time, she will have traveled more distance, and you'll get this blurry effect from the motion blur. And here we have an image of a waterfall that is taken at 1/30th of a second and also at 15 seconds. And you see this kind of long exposure and smooth, streaky nature of the 15-second one because it's taking the movement of the water during the entire 15 seconds into account and not just the fraction of a second on the left side, which will make it look much sharper. ISO is a bit different than aperture and shutter speed. ISO used to refer to the sensitivity level of film stock in film cameras. So different types of film stocks had different sensitivity to light. So if you were shooting at a low light situation, you might want to pick a film stock with a higher ISO so that it could absorb more light and you'd get more exposure of the image when you processed it. ISO actually stands for International Organization of Standards, which is the most boring name that anybody has ever come up with, but it essentially regulated the sensitivity levels of the film so that the numbers actually meant something and were kind of standardized so that people could reliably know what they would get by picking that film stock. With the film stock, higher ISO numbers would increase the exposure of the image, but it would also reveal more grain. And this had to do with the different materials that they were using for the different film stocks. So as the ISO number got higher and more sensitive, the more grain would appear. With digital cameras, the sensors only have one sensitivity level. So better cameras are more sensitive and worse cameras are less sensitive, but they have only one level. But ISO is kept on digital cameras, and I guess we can refer to that as digital ISO. But digital ISO actually refers to the amplification or what intensity multiplier of the analog signal before it gets converted to digital data. Digital ISO is a lot like a volume knob on a radio. If the signal is weak, aka there's not much light making it to the sensor, then increasing the volume will make the sound louder and make the image brighter. But it will also increase the static or the digital noise, sometimes referred to as grain. And that is just because the static always exists, and by increasing the volume, you're not only increasing the volume of, the thing that you're trying to listen to, but you're also increasing the volume of the static so you hear it more. And that is sort of the same thing with the digital noise. The sensor always has a bit of noise, and by cranking up the ISO, multiplying it by a lot, then you see more of that noise variation. And going back to our exposure triangle, only aperture and shutter speed are referring to how much light is actually hitting the sensor, and ISO is more of a multiplier of that signal before it gets converted digitally. I want to bring attention to the actual numbers that these settings are using. Let's say I start on 1/30th shutter speed. You'll see that the next available option is 1/15th, and then the one to the other side is 60th. So basically half and double. And that keeps doubling. So 60, 125, there's a bit of rounding going on here, but that's double. And then 125 is half of 250. It's another double. And then 500, and then 1,000. And so there's a bit of rounding here, but essentially it's always halving. Half, half, and half. When we go to ISO, we find the same thing. Let's start at 1600, and then we have 32, 64, 128. On the other side, we have 800, 400, 200, 100. So it's basically just half, 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 double, double, double. There's actually an amazing website that I stumbled across called andersonimages.com, where he has an exposure simulator. And this is sort of simulating the relationship here between our three settings of our exposure triangle. And he has this whole cool website set up to be very interactive. Up in the top left here is showing us our exposure. So this line here means that it's properly exposed, or as exposed as we want to be. So that's our starting point. And as I move these around, you can see that it's either going up in exposure or down in exposure. And this is trying to teach us how to balance the exposure out. So as we just discussed, these numbers are kind of doubling and halving each time, and they're representing one stop of exposure. So if I were to increase the shutter speed, it would darken the image. So then I would need to choose one of these other options, perhaps ISO, and it's bringing that exposure back to the center there. And as you can see here, if I go too high with the ISO, let's say I need to shift the aperture now back, you can see that the image is getting grainier. You can see when I'm adjusting the aperture, like the bokeh shapes in the background are changing. So this is teaching us how the different types of settings are affecting the image, whether it be bokeh or motion blur or graininess. So I think it's really cool. I'm going to link this in the video and in the notes on the blog post. So please check it out. Or if you have a DSLR camera yourself, go ahead and try these settings out with all this stuff in mind. But then you get to aperture and you notice that these numbers are not doubling anymore. And I always found that a bit frustrating. I didn't quite understand, because if you are on f11, f16 is actually double the brightness of f11, even though the number is not double. So I thought, okay, what's going on here? So why don't the aperture values kind of double in half like the rest of the values? And they're kind of giving these strange numbers along the scale. So let's try to demystify the meaning of f-stop and f-numbers, which are these numbers on the settings of the aperture. So why are they written like that? Formally, the f-number equals focal length divided by the aperture diameter, and that is the distance across of the whole of the opening of the lens. If we use f for the focal length and d for the diameter, we get a little equation here, which is f divided by d, or f over d. So imagine that we had a 50 millimeter lens, and that's the focal length. So that is the number that is going to go up here in the f. And so we have two different aperture settings here. On the left side, we have an aperture of f2. And so in order to get our aperture diameter, which is that distance across of the hole, we are going to take the focal length divided by 2, and that gives us 25 millimeter diameter. The radius is half the diameter, so that's d divided by 2, or 25 divided by 2, and that gives us a radius of 12.5. On the other side, we have an aperture of f8, so let's see what that does. To get the diameter, again, we're going to take 50 millimeters, and this time divided by 8, and we get a 6.25 millimeter diameter. And once again, the radius is half of that diameter, so that would be 3.125. And 6.25 millimeters is a lot smaller than 25. And it's kind of illustrated in these two photos here, where maybe this one would be 2 and this one would be 8, so it's gotten a lot smaller. So the f divided by notation is just a convenient shorthand to say the aperture diameter is some fraction of the focal length. So 1/2 of the focal length, or 1/8 of the focal length, or 1/16 of the focal length. And they're called f-stops because each stop, which would be one of these notches of the setting here, roughly halves or doubles the amount of light that is emitted into the camera. So I hope that clarifies things a little bit. This is basically a ratio of how big the circle opening is of the lens compared to the focal length of the lens. This is for sure the nerdiest part of the video, so brace yourself. But the aperture is referring to the light going through the hole in the camera, right? So if we want to double the amount of light that is reaching our sensor, we have to actually double the area of the circle. The area is not the radius, it's not the circumference, it's all like what fits inside of the circle, right? And if we take a time machine back to math class, doubling the radius of a circle does not actually double the area. It actually quadruples it because it's squared, right? So 2 squared is 4, and 4 squared is 16, or 2 times 2, right? So when we double the radius, we're actually quadrupling the area each time. So what do we need to multiply the radius by to get double the area? So this is the equation that we're going to try to figure out, and we've doubled the area, and we're trying to solve for x. So what do we need to multiply the radius by in order to get double the area? So first we're going to replace a with pi r squared. That's the area here. It's a beautiful, beautiful illustration there. And then we get this kind of full equation here after we've replaced that. And again, we're trying to solve for x. I find this pi parentheses xr squared a little bit harder to read. So this also could be represented by pi x squared times r squared. So then we could just play that little cancellation game that we used to play in math class. So we cancel out the pi from both sides, and we can cancel out the r squared from both sides. And so this turns into x squared equals 2. And then how do you isolate x? Well, you have to do the square root of 2. So you do square root on this side, it gets rid of the exponent, and it goes square root of 2. So we need to multiply the radius by the square root of 2 in order to get double the area, double the amount of light. And the square root of 2 is approximately 1.4142, so approximately 1.4. So going back to those mysterious numbers that we saw a second ago, you can actually see the numbers going up, multiplying by 1.4. So it's multiplying by the square root of 2, or around 1.4 each time. So 1, 1.4, 2, 2.8. And you can actually see that every other time it's doubling. So 2, 4, 8, 16. And that's because, square root of 2 times square root of 2 is 2. So I never understood these numbers on the aperture until I made this video and did a little research. I knew that each one of those numbers represented that the image would go up by 1 stop. To me, it was really cool to find out that it had to do with the fact that the area was doubling. So literally the circle is doubling in size, or the amount of light that can go through it. And that wasn't simply times 2 from a mathematical point of view. It was times square root of 2 and 1.4, which totally explains why everything kind of multiplies by 1.4. And maybe the only thing left to remember is that this is a fraction, and so 1/2, for example, is bigger than 1/8, right? And so the bigger the number, it actually means that the whole of the lens is getting smaller, and that means less light will come through, and the image will be darker. Jumping into Nuke now, we can actually put this exposure stuff into practice, and probably the most obvious color correction node that you could use to adjust exposure is the exposure node. So there's a node called exposure here, and the one thing that I would suggest is that you always keep it in stops. I think it comes in densities from the start, but either change it in your defaults or just remember to change it as you do it. The math is being done for us so that as I go up, so 1 stop higher would be double, 2 would be times 4, 3 would be times 8, or if we go the opposite direction, -1 stop would be half, and then 1/4, 1/8. So it's getting double as bright or half as bright. Of course, you don't need to use an exposure node. It's just a little bit easier maybe to do a note right away if the VFX supervisor says, hey, I want that 1 stop lower. But of course, we can just use a regular multiply node because it's just multiply math. So if I were to expose this image up 1, I would just multiply by 2, and these would be the same image here. And if I were to expose up again, so expose it 2 stops, I would need to multiply it times 4. And you'll see I'm getting the same image. And so if I go the other way with the stops, if I go down 1 stop, that would be multiplying by 1/2. You can see that's the same. And if I go down further, 1/2 of a half is 1/4 or 0.25, right? And if I were to go 1 more stop, you can actually do math by typing it in the knob value. So if I just did times 0.5, we'd get 0.125. And of course, every grade node has a multiply or a gain, and gain and multiply, the same exact action, there's different name. So for example, if we took this 0.125 and we put it on the multiply of the grade, now they're all the same. And I have an example here where you can actually use the number from the exposure node to drive the multiply. So I want to show that it really is completely related and you can get the same exact math. There is an equation that we would have to use, and it is POW parentheses 2 comma x, and x being exposure and stops, let's say. So if I just open up this expression, you will see it is POW 2 comma and then exposure 3 dot red. So I'm literally taking this value here and putting it there as the x. And I found that this expression is a little bit hard to kind of understand. So I just wrote it in a different way up here. And so this expression is meant, it's 2, that's where this 2 comes from, to the power of x. So the exponent in this case is the exposure number. That's the number in stops there that we're giving it. So if instead of x, we want to give it an actual number, and I just come over here, I'm going to use the value of the exposure node, we can see what it is actually doing. So it's actually doing the math there, but let's stick to whole numbers here. So you can see that it is going up exponentially as we do that. So in other words, half, 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 double, double, double. So yeah, you're able to get that math, that same exact math from the exposure node on any multiply by just using this equation here and then feeding the stops into that second number there. Now that we talked about exposure, let's talk about temperature, which is what color the lights are. Temperature describes the hue or color of the light measured in Kelvin or K. Heated objects emit light photons as they heat up in a process called blackbody radiation. As objects get hotter, they emit different frequency wavelengths of light, shifting from red to orange to white to blue. And this scale or measurement is used quite a bit in the world of lights because we need a way to figure out what color the light is going to be. And if we go off the Kelvin scale here, if you give any given number, you'll see that it's either a warmer light or a bluer light or kind of neutral in the middle. And we have a representation here of the Kelvin scale getting higher and higher, and it goes from this warm to a neutral to a blue light. Let's take a look at some examples where we see the colors of these lights happening in the real world. And the first and the lowest would be red. And that's just when things are starting to heat up. And you'll see this a lot in hot coals, or if you look into your toaster. And that is sort of right when metal starts to get hot. It'll heat up into this warm tone that you've probably seen before. As you get higher in the temperature, you start reaching this yellowish orange or a more neutral white. And that is the Kelvin range of most light bulbs. That's why our light bulbs are either kind of warm or neutral colored. And then as we get to extremely high temperatures, the color starts to shift more blue. And so the hottest part of a flame would be blue. And you can see this in examples such as a welding torch, which is being used to melt metal, a gas stove at the very base where the gas is coming out, or a rocket engine, for example, where at the hottest point it is blue flames that are coming out, and then as the flames cool, they are turning more into that warmish red tone. So that is the origin of the word temperature. It's actually referring to different temperatures releasing different colors of light in the real world. And what we really want to take away from this is that this is a scale going from kind of reddish orange all the way neutral and then blue. Those are the different tones or hues that we're talking about when we're talking about temperature. So jumping back into Nuke, how can we adjust our colors or our temperature? And there is probably a dozen ways to do this. I'm just going to talk about how I think about stuff when it comes to color corrections in Nuke, and hopefully you'll take something out of that and can use it in your own color correction process. But I tend to think of things in terms of multiplication. And if I have this blue constant here and I multiply it with Marcy here, she'll turn blue. And if I have this warm constant, she will turn warmer. So you can really multiply something towards any color. So let's say I have a green constant here. Yeah, she'll turn green. So, to me, it's a very simple way of looking at it. It's like, I want to go towards this color. And so here's the color that I want to go towards. And the image shifts towards that color. And of course, there is a multiply knob on the grade node that we can use for this. And if I just take the constant color of this blue constant, I had it at red 0.5, green 1, blue 1.5. And if I just enter those values into the same grade node, it's just a multiply. So whether or not you do it on the side like this or with a grade, you'll get the same result. You have to be careful though, because if you start adjusting these values of the multiply to make something more red, let's take down the green and the blue, the image will get definitely more red, right? So here is a good example. But we've actually changed the luminance of our original image. So yes, it's become warmer, let's say. Let's make it a little less red. So it's become warmer, but it's also gone down in intensity or brightness, right? And in the corner of the viewer, there's a little L for luminance here, and it's saying 0.149, so 0.15. And if I look at the end result, so I'm down here really low. I'm down at 0.05. So I went down quite a bit. When a VFX soup says, please make it warmer, they don't want you to change the intensity of the image. Usually they just want to see the same image, but in a warmer tone. So how can we ensure that while we're changing these multiply numbers around, we are not messing with the luminance of the image? And just a quick disclaimer here, I'm talking about color correction, which is a very diverse topic, and everyone has their own way to color correct. And this is just how I color correct and how I've learned over the years to achieve the effect that I want in a very simple way. So take everything I say with a grain of salt. Maybe you can learn the way that I think about color and how to adjust colors and everything in Nuke, and perhaps take that into your toolkit at work. Everything I say is not set in stone somewhere. So I'm just describing how I understand this process. So I would say that, when you're starting out with a grade node, when you're kind of a beginner, probably you're open up these 4 settings here that expose red, green, blue, and probably you're just dragging or entering numbers here. But that is what I mentioned before, where you're not taking luminance into consideration. And when you open up this tab, you've seen this before. This is really just exposing the same values that we just saw as sliders, right? So it not too helpful in thinking about it in a different way. But over here, I don't know why they have done this, but they've included some very important settings in a very small way here. So I never ever actually use this mode of color correction. I see it all the time. It's fine if you want to use it, but I recommend just for fine tuning reasons, always opening up this panel here. And if you're using Nuke, beyond, I forget what version they changed this, Nuke 11 or 10, you might have to control click on this little color wheel here to get it up. Now, if you go to the preferences and you go to panels, control panels, you can choose whether or not you want to use the in color picker or the floating color picker, which is the one that I'm looking at right here. And so then you wouldn't have to use control. You can just click it like I do here and it'll pop up. And then in order to get the other one, you have to control click. So just in case you want to change this for the future. But here we have a bigger panel. And I'm pretty sure when most people open this, it comes in exactly like this here. And so we're seeing hue, saturation, and value. We're seeing RGB. Those are the same values that we're seeing in the front-facing knob here. The alpha is off to the side here. We have a bunch of color swatches that we could choose from, and then we have a classic color wheel, right? So you could like swirl around the color wheel. So I think the most important one is actually the one that is hidden by default, which is TMI, temperature, magenta, and intensity. And you notice that the T, the temperature, is actually reflecting exactly what we were just talking about, the temperature going from warm colors to a more neutral tone and then off to blue. Now, of course, that is missing some colors, right? It's missing greens and purples and magentas and stuff. So then we have our magenta, which we can shift things more green or more magenta. And then we have our intensity, which is essentially our luminance or brightness of the image. So I'm going to set this back to default so you can see how it's going to look when we open up all these settings here. And you can see if I just want to make an image bluer, I just make it more blue by dragging it in the blue. So if I wanted to make it greener, I would just drag it here in the green. So one of the things you'll notice is that it's not really changing our luminance too much. Of course, it's going to be a thing where some colors, if you shift them towards that color, is going to change the luminance because those colors appear to be brighter than other colors. But for the most part, our luminance is staying the same, which is great because that allows you to hit that note of change the color but don't change the luminance. Another way to think of it is that temperature and magenta are controlling the color and intensity is controlling the exposure. So let's go back to our example where we had the grade that was making it more red, but decreasing the luminance too much. And so let's take a look at what the panel is indicating to us. So here you can see that the intensity has dropped quite a bit. So from its baseline of 1, it's gone down. So if I were to bring that back up to 1, then basically I've entered this color, but I haven't changed the luminance. So if I'm shifting the image warmer or more red, what I wanted to do, but I am not changing the overall intensity of the image so much. So this is a really great way to change colors while being mindful of the luminance. So if you didn't want to change luminance, you would keep this intensity at 1, and then you would mess with the colors. Or you could even go back in here and change this intensity 1 after you've messed with the colors, just to make extra sure that you didn't change the luminance too much. And you'll also notice that I made the image more red, which is neither like orange or magenta, but it's somewhere in between, as you can see by the color wheel. And so, I went a little bit warmer in the temperature and a little bit more magenta in the magenta scale. I think it takes a little bit of practice, but I do still think it's pretty intuitive. And, as artists, we want to just move things towards the color that we want them to go. So this is kind of my preferred way to adjust colors in Nuke. I actually go one step further than that, and I like to divide my color and my intensity or my exposure into 2 separate knobs so that I can control the intensity and the color separately. And luckily, in a grade node, we have gain and multiply, which are essentially the same thing, right? So I'll just kind of prove it here, but different names, same value. So if I do gain of 2, and then here I do multiply of 2, guess what? They're both multiplied by 2. And so because they are both multiplication, just going by a different name, I tend to always do my color on the multiply. So let's say I make this more red, like the other example. And then if I want to adjust the intensity of the image, then I have this free gain here where I can start entering values. And then I could even think about things like exposure, like, okay, let me go 2 stops up, which would be times 4, as we showed in the other examples. Now, because these are both multiplies, of course, you could go the other way around, right? You could use your gain always for the color and your multiply always for intensity. But essentially, this is the way that I color correct in Nuke. So I'm always using one for the intensity, and then I'm using the other one to control the color. I'll give a final example of why I like this separation so much. So let's say that I had the same grade, but instead of the gain, we left it alone. So now I've turned the image greener. But let's say I also now I want to adjust I want to make it one stop brighter on top of that. So here we have all the sliders, and I guess I could start messing around. Maybe I would make the value 2. It's a bit hard to know exactly if this 2, because it started at, you know, whatever that number was, that it was 1.2 or something. It's harder to know exactly how high I need to go with any value exactly. Otherwise, I'm just sort of randomly pulling them up. But let's say, yeah, I don't know, let's say I'm going here. So when I'm finished with my color correction, you see that I've adjusted the numbers, but you can't really tell like how much more exposed it is. In this example of this grade where I adjusted the gain, I can tell that number 1, I shifted it more green, and number 2, I went up in exposure by 1 stop, because I definitely went up and multiplied it by 2. So that was me going up exactly 1 stop in exposure, and then I color corrected it to be green, and that green color correction of the multiply, I kept the luminance the same. So the gain is referring to how high I went up in exposure, and the multiply is telling me what color I shifted it to. And this is the difference here between these numbers and sort of this separation where you have the ability to later make intelligent changes. So if my VFX soup says actually take it a half a stop down, that would be like 1.5, for example. So now I don't need to go mess with these numbers at all, because my luminance value was right there to adjust. So that's it in a nutshell. I really love this temperature magenta intensity. I use it almost exclusively unless I need to exactly match channel by channel. I will make a shout out to any like colorblind compositors out there. This might not be the most intuitive way for you, and you might like to, you know, adjust this red, green, blue, but you can still take value off of knowing that the intensity is changing. So to take advantage of this slider still, even if you are adjusting these values to match a reference or something like that. So it is still useful to have this open, I would say. And in general, I would really convince everybody to try to use this panel in its full extended form here, because I thought when they changed this panel here, that is for me the most important thing that I was adjusting, and it is the smallest and most inconvenient thing to adjust in these little tiny settings. So it was a sin, and there's no way to change them either. I can't make them go in the place of RGB. So for me, I was very disgusted by this open panel here. But hey, you know, to each their own. Everyone can color correct in their own way. This is just how I like to color correct, and I hope maybe you learned something from it. So I'm going to come back to my Blender Light Group rebuild, and let's just say that we messed around in comp quite a bit. The changes are faster here, so we can get an entirely different look of the scene by just adjusting all the lights. So you can see it's quite a different aesthetic. Maybe it's a spooky mood or something. So I'm just using the principles that we talked about earlier with exposure nodes, and then the grades only adjusting the multiply for the color. And I've sort of changed some colors and exposures of the lights around and shaped the scene into a different mood. And one of the biggest reasons why we would want to adjust things in terms of exposure and then multiply for color is that every lighting software usually has exposure and multiply as the settings of the lights themselves that they can adjust. And that is how lighters are adjusting the lights and changing the color or temperature of the light and the exposure. So what that means is actually we could feed the lighters back this information. So if I told the lighter, go to the key light that's in your scene and go -1 exposure, and then here's the number to multiply it by, theoretically, if they changed all the lights in the same way that I've just changed the lights in my comp, they can render a new image that will basically round trip it, and the next time they render, it would look like this image here, and it would be even a little bit more accurate. because adjusting in comp is always a little bit of a cheat, right? So this is a great way to communicate with the lighter, or if you are a lighter yourself, you can just simply comp like this and then use those values back in your lighting software. So you can get that real-time interaction of like making things brighter and darker here, but then you can just feed those values right back into your lighting software and hopefully get the same result when you render the next time. So it's incredibly valuable to think in terms of exposure and multiply for color. I'd like to go over a few other examples of color corrections that you might be doing with the lights, and one of which would be saturation of the lights. So these are the individual lights, right? And as you might have guessed, it's not just the lighting information that you're seeing here, it's all the material information too. That's why things are different colors. So if I wanted to desaturate this light, for example, probably the worst thing I could do is take this and desaturate it like that, because obviously this is not what a desaturated light color would look like. Rather, this is the whole scene that is desaturated. And I guess a way to think about this is these are individual beauty renders in a way where only one light is showing and then they all add up to the final scene. So just like a beauty render, if I just took the saturation and desaturated it, it would desaturate everything in the scene, right? Going back to our Material AOV rebuild for a second, we had a similar situation where we had some diffuse lighting, but that was the color of the diffuse materials and also the color of the light. And so we had this color map or texture map, or however you want to say it, and we would divide that so that we could get the pure lighting information. And so we're going to use a very similar concept. So if we take this junkyard scene again, we have a diffuse color for that. And what we could do is per light, we could try to like divide the scene by the diffuse color and getting kind of the raw lighting of that light. And then we could, for example, desaturate that and multiply it back. And then you'll see that it is much more true to desaturating the actual light as opposed to desaturating everything. And so you could do this with all the light groups, for example, and start to get more neutral tones in there. And I'll just show you like a before and after. So here's a little bit more neutral tones, but this starts to kind of break a little bit of things because it's not perfect. Like the diffuse texture and everything is not exactly perfect. And it's got also the specular items in there. So I probably wouldn't recommend actually this way to do it, but just to show you kind of an example of, okay, you're trying to desaturate the light, but you're also desaturating the material colors. So what would you do? And so I think a much more elegant solution would be just to shift the light colors to a more neutral tone, just with a simple color correction with a multiply, for example. And here we're showing that we're just shifting these colors a little bit. So here's like a before and after. And here is the end result, which should have some less problems than the other solution. And it turns out to be an equally neutral type of scene. So you could just do this by eye. For example, you could just go in here, say this is a warmer light. Well, we have this nice tone here, and something like that maybe would be more neutral. And we're playing with just the temperature here like we showed in the other examples. Something else that you could do is that you could select the white point. So how could you neutralize or white balance a shot? Well, you could pick something in here that is supposed to be white. And in this example, I don't know, I think this scale probably is supposed to be white. So if we pick that, obviously the image will get brighter now because we've just made that white. But then we could just use the gain to bring it back down. So with just a little bit of finessing here, we can find around where it was. So that's about it. We select something that we know is white, and then we just play with the luminance to, match it closer to the original. But two perfectly reasonable ways to neutralize the light color. And what we're seeing here is the material color that it would have been in a more neutral tone. Now you have to worry about things like if you have multiple colored lights in the same light group, then you don't know which one to color correct towards. But in general, for one color light solutions, this is working pretty good. And I would say that it fulfills our goal, which was to neutralize or white balance the lights in the scene. So just shifting the colors to more neutral tones should do the trick. So there is also another reason why I prefer to work with exposure and multiply. And if you were kind of paying attention, you'll notice that exposure and multiply, they're both just multiplication. And of course, there are other types of color corrections out there, like gamma and color correct and stuff. But I tend to try to avoid those until I absolutely need them. And while they're perfectly reasonable to use, they come with some issues that I'll try to clarify right now that you should be mindful of. The first example I'll show is using a gamma correction. You can use a gamma correction, and also you can reverse it pretty much exactly the same as how it was. I actually don't see any difference here. So it is reversible. However, it requires a specific order of operations in order to reverse. So if we basically draw a line in the sand here, we have to gamma right after the previous gamma, right? So we have to restore it. So if I look at the bottom, if we start changing the order of these, then they're not going to work as well. So you can actually screw up kind of the order of operations and it won't return you back to the same result. So the order is quite important, whereas when you're using multiply, for example, I have all these exposures here, but I carefully made sure I was doing the opposite. And when we run this whole thing through, I get the same result. But not only that, but I could take this one and just move it around. I'm hitting control up and down on the arrow keys here. So it doesn't really matter because, in math multiplication, you can multiply, you can switch all the numbers around and it won't really matter. Gamma is messing with the midtones. And so in order to mess with the midtones, you need to know what the midtones are. And if you've changed what the midtones are, then, well, you get a different result, if that makes any sense. And just to ensure that I'm not playing any tricks on you, I did the same with this multiplication here. So I just converted all the values here, and I could take this 8, and absolutely I'm getting the same result. So in other words, the order does not matter, and you can return to the original results very easily. Now you can return with gamma too, but it's just you have to be a bit more mindful of where you're putting it, and okay, now I need to reverse it exactly. So in a big tree of color corrections, this can get quite complicated of trying to then go ahead and reverse the previous gamma that you did. It's not as easy as just, oh, I did a gamma up at the top, so let me just throw a gamma and try to reverse it. It's a little bit more difficult than that. So I just want you to be mindful of that. And in this part of the video, I'm going to make a lot of compositors very angry. And it has to do with color correction shenanigans. And I know people love the color correct node. It makes sense, you're messing with your midtones and highlights and you can do everything all in one. But there's a real big problem with the color correction node. And one of them is that it is a destructive workflow. So I'll give you a quick example here. On the left, we have a simple grade node. It's a multiply. And let's just take some easy numbers, right? So we're going to do 2 in red and 0.5 in blue. We can just reverse those numbers, right? We can just put 2 in blue and 0.5, and we have gotten back exactly to the beginning because it's a multiply, and you can reverse it. You can just get back to the original. Now we have a problem with the color correction, where if we have a color correction node, and I've tried to just take some basic settings here like saturation, game, gamma, and I've done something to each of these ones, and I tried very, very hard to reverse this in the same way that I did in the other ones. And if you do that, you just will not be able to go back to the original. So color correct nodes, when you're using the shadows, midtones, highlights, are basically impossible to reverse. And there's a pretty good reason for that. Let's take this color correction node and actually try to do it with nodes themselves instead of doing it all in one in the color correct node. And we can get pretty close. Essentially, what a color correct node is doing is it's taking luminance key of the shadows and the midtones and the highlights, and then it's applying these color corrections in that order to them. So we could do something similar, right? We could make a luminance key for just our shadows, and we could apply the same color corrects to them, and then we could do the same thing for our midtones, and then apply those color corrections, and then we could do the same thing with our highlights, and isolate all those and do those color correction. And I know that the node itself does everything kind of all in one, and just to point out, the luma key on the color corrections are always kind of with an S-curve smoothed out, and the ones on the luminance key are more linear, right? So it's always going to be a bit different. So what I've done is I have a starting point, and I'm doing a key on the midtones and the shadows and the brights, right? So it depends on my input, what my luma keys are that are going to drive the various color corrections that I'm doing for that section. So what happens if we try to reverse it? Well, now I'm going to go for the shadow, and the shadow of the second color correct is going to look different than the shadow of the first color correct, because I've changed the luminance and everything of the image, of course. So when I try to do another key on top of the other one that I've already changed, it's not going to be the same result. And the same with the midtones. Let's take a look at that. So these two midtones are going to be different, and also the highlights are going to be different. So when it tries to go reverse all that stuff, it's not grabbing the same ranges that it once did. We might be able to get a little bit closer by, instead of the new starting point for the luma keys, by using the original. So if we plug this into the original stream, so at least my luminance keys are the same, but even then, you don't get the same result from the beauty. It's nowhere near it, right? And that just has to do with all the gamma changes and saturation changes that were done, and they're just out of order now, and so you're just not really able to get back to the same result. And if you ever wanted to tell a lighter like how to achieve this look, it would be next to impossible because the lighter cannot affect all these like midtones and everything within the light themselves. And you might say, well, how often am I trying to color correct and then reverse to color correct? Maybe that's not a big deal, but there are a couple other problems as well. And one of them is that if the luminance of the input changes above the color correction, well, the color correction had a luma key that is driving those settings. So if you start changing above the color correction, it's going to also change the look. And so let's just say we had an example where we have a color correction here and we expose down, did some color corrections and then expose back up. And let's just say like we remove those exposures. So if we were to do this off to the side, these should cancel each other out, right? So if I do this and disable them, the image doesn't change because they're just multiplied back and forth. But because I changed the exposure, the color correction changes above it. So you're essentially node locked in there, and it can make making changes to nodes that you've already put down above the color correction very difficult. So it kind of locks you into place in a way. So you have to be very, very careful about changing the source. I mean, how often have you had it so, you have this color correction here, and now, you got the note to remove that. But you're not just removing the exposure anymore, you're actually changing the color correct node, which can be a major problem when trying to go back and address notes that you're giving off something that you've done. And the classic example is all of these color corrects that are stacked on top of each other. And if you imagine, each color correct is dependent on the result of all the previous color corrects. So in other words, it's a little bit like painting, where you can't click the undo button or you can't go back, right? If you make a mistake, you're just going to have to paint over it or like add more brushstrokes on top of it to cover the mistake. So if you pick up something like this in your script and you need to make a change, it's almost not even worth trying to go back and adjust those settings. You might as well just keep adding more to the bottom to make those changes, or just start over, because like changing one of these has a cascading effect down the chain. They're all dependent on each other, and you could be completely screwing up like the whole image. So let's just say, okay, now I want to make this brighter. I'm doing all kinds of crazy stuff now that I might not think that I am doing. So this can be a really, really destructive way to work. And when I say destructive, it means, okay, you've started going down, and there's not really a way to reverse it all the way to get back to the original before, like those multiplies were able to. I try to avoid using color corrects whenever I can. If I need a saturation change, I just throw in a saturation node. And I know that people really love these nodes, and you might say, I can't live without this node. I never want to comp without this node. And that's perfectly fine. I just want you to be aware that you might be creating a knot that is impossible to untangle. And here is my advice to you, and I'll put it up with a big disclaimer. Of course, at the end of the day, we are compositors, and we're trying to get a specific result. If you need to use gamma color corrections or whatever node that you want, then that's what you have to do to get the image done. My advice would be to try to start using exposure and multiply for the luminance and color. Try doing that first as a first result instead of using the color correct, right away. Because you're already starting from a point where you might not be able to reverse from. I think it's better to try to get to your results with the color corrections that you have here, and probably you'll get there right away. And if you did, that's great, because you could also reverse it at any time. So you've saved yourself some trouble. But of course, if you want to put some random color corrections and stuff in the script, I would say just do it at the end. Like when you run out of resources, you can't get there with any other way of adjusting the color or luminance of the light, then go ahead and knock yourself out with the color corrects. I would like to see more compositors start to work in a non-destructive way first, to get as far as they can, and then of course, to get the shot across the finish line if other things are not working, to start to use those more destructive nodes like color correct at the very end. And just being mindful of what you are getting yourself into in those situations, and also being mindful that you would never be able to bring those changes back into a lighting scene in order to re-render those and get the same results. So you're kind of deviating from this non-destructive workflow. So that's my 2 cents, and I know I'm going to get a lot of hate for crapping all over the color correction node, but at least I thought I would explain some of the reasoning here of like the destructive versus non-destructive workflow and kind of using it as a last resort. Just be mindful of the path that you're walking down as you use some of those more destructive workflows. So to recap everything, we have our Material AOV rebuild here, which is for adjusting our materials. And then we have a light group rebuild here, which is for adjusting the lights and rebuilding back to the beauty. So these both rebuild back to the beauty in separate ways. Of course, in this example, I've rendered out all of the fruit bowls where you can see the different types of light groups. Here they are. And they are slightly different due to the renderer and I think the scenes that we're making. But in general, they have the same lights that you can mess around there or mess around with the Blender render that I am providing as well, that also have the light groups. And I'm giving you a Redshift, an Arnold, and an Octane render as usual, and then the Blender render from the Blender scene of the junkyard. So that's everything that I kind of wanted to talk about light groups today. Light groups are incredibly important, as you can see from this kind of evolving image of setting how a scene looks. Of course, different colors and different intensities of each light can really shape an image around even a simple image like this fruit bowl. I would say when I first started doing compositing like 15 years ago or so, that it was much more common to see the Material AOVs. And as the years have gone on, the importance of rendering light groups and maybe even predominantly using light groups in your comp, or exclusively using light groups and comps. Like, for example, if you're doing a feature animation film, it could be much more important to adjust the lights instead of adjusting the materials, which are supposed to be like finalized. Materials tend to be more useful when you're matching materials that are already existing. So in other words, CG comps that are comping onto a real plate. And light groups tend to be more important when you're kind of a lighting artist who is shaping the scene after the fact so that you don't have to wait for those render times. You can be a bit more interactive with it. They both definitely have an importance. On the left side here, I have some random light changes, and on the right side, I have some random AOV changes, and it's sort of evolving, and you can see, the different types of effects that you would get from either adjusting the materials of the objects or the lights in the scene. And your question might be, okay, but how do I adjust the materials and the lights all at the same time? And that is something that we are going to cover on the next video. So yeah, how to use everything that we've learned together combined to adjust everything to the full potential of your comp. So please stay tuned for that one. I'm Tony Lyons. Thank you for watching, and I'll see you next time.